In this series of videos, we are going to solve several pleasing math problems. That means, we get answers that's kind of beautiful, I should say. So I'm going to say so beautiful math problems. Beautiful math problems. So this is problem number 1. So problem number 1. So let's try to do this one. So let's say find the length of the curve. Find the length of the curve. Find the length of the curve. Y equal natural log cosine x. Y equal natural log cosine x from x equal pi over 6 to pi over 4. So let's try to do this problem. So what we're trying to do, we know that if you want to find the answer, if you want to find a length, so let's say you have a curve. So I'm just going with a general curve. So let's say you have a curve like that. So that's going to start with A to B, and if you want to find the length, so we're going to call it L. So we have a length formula. So what's the length formula? So we know that the length equal A to B 1 plus dy over dx squared square root dx. So that's the length formula. So what we need to do is we need to find the derivative, and then we're gonna plug in here. So we can use the formula. So we know that y equal ln cosine x. So then so this says that the y prime is it's a log function, so the function goes down and the derivative goes to the top. So that means you can simplify this one as negative tan x. Now we're gonna plug in that into the formula. So the length is equals to so the limits of the function is going from so we can see that so it is pi over 6 to pi over 4, and so if you plug in that, then you're gonna get 1 plus dy by dx is negative tan x. So that means when you square, so you're gonna get tan squared x square root d theta. This is easy to integrate. So when you integrate, actually 1 plus tan squared theta is secant square theta, and once you take the square root, so you're gonna get pi over 6 to pi over 4 secant theta d theta, and we know that the secant has a integral of ln secant theta plus tan theta. That's the natural that's the integral of that, and then we can evaluate this at pi over 4 and pi over 6. So let's plug in the values. So when you plug in the values, what's going to happen? So it is ln, we're going to plug in pi over 4, so this is secant pi over 4 plus tan pi over 4 minus ln secant pi over 6 plus tan pi over 6. So what's going to happen is ln secant pi over 4 is square root 2, and tan pi over 6 is square root 1. So this is 1, so you're gonna get 1 here, so you're gonna get 1, and then minus ln, so you're gonna get secant pi over 6. Secant pi over 6 is 2 over square root 3 plus tan pi over 6 is 1 over square root 3. So and then we can simplify. So what's gonna happen, so we're gonna get the length as, so the length equal ln, so we have square root 2 plus 1 minus, you can simplify the one as 3 over square root 3, that means square root 3, and then we can combine these two to get ln, so it's a division, so you're gonna get 1 plus square root 2 over square root 3. So that means finally you can write this one in a very pleasing form. You can write this one as square root 1, square root 2, and square root 3. So so that's the answer. So that's the length of the curve. And so we're gonna do similar problems like that in this series. So if you know any such beautiful problems, you can email me.